Okay, guys, so this is where we left off last time with the Excel report. Um, we took the data from the ICP, which included standards and then unspiked, spiked, method blank, and validation. We plotted them, we regressed them, we got a slope and intercept. We computed the concentration and standard deviation of each of the predicted Y values there. Now, what I'd like to do right now is I'd like to add in the values for milligrams per tablet and include their confidence intervals in this. So what I'm going to do is I'm going to make some space off here to the right. So I'm going to insert column V, insert W and V, and then insert a bunch more here. Yeah, let's see, let's go on over here. And there we go. So that's about right. Maybe insert a couple more columns here. All right, so there we've got these. Now, in order to go from concentration to milligrams per tablet, we need to know what our uh, what our sample preparation was, and that's basically taking the tablet, dissolving it in 0.1 liters or 100 mils, then taking 10 mils of that and diluting that to 100 mils, right? That's how we prepared the sample for ICP. And that's all we need to know to get from the concentration in the ICP back to the milligrams per tablet. So I'm just going to give a few labels here. V1, V2, and V3, right? Oops, V dot 3. And let's see, I actually need to add another column in here. And then V1, this is going to be the what the tablet was dissolved in. And I'll just do all these in liters to keep it simple, but that was 0.1 liters, right? And then V2 was the aliquot that we took out, and that's going to be 10 milliliters or 0.01 liters. And then V3 is the amount we diluted it to, which was probably also 0.1 liters, right? So I'll just make these a little bit more precise. And then I'll make this guy more precise. And then, so this is going to be the values. Then we need the uncertainties in those values in order to do the error propagation. And the so that's between the SV1, SV2, and SV3 there. And for a guesstimate here, I'm going to take 1% of the total volumes, right? So this is going to be 0.001. This is going to be 0.0001, right? And this is going to be 0.001, right? And so I'll get some, I'm going to name these cells. I'm going to name 0.1 v.1, 0.01 v.2, etc. The way I do that is I highlight these and then I go up to formulas, create from selection, and it guesses that the names are in the top row, and I say okay. And then I do the same thing down here. And now we see that when we're on that cell, the cell address is changed to v.1. So that makes it a nice way to absolutely address these cells, right? So now let's put the unit here. It's going to be ppm, right? That's in the previous experiment. We got results in parts per million. Now we're going to go to the result in amount in units of milligrams. So let's see here. Actually, I'm going to put this down here. Yes, amount right here, sorry. And so the amount of, let's say, this first one was, get what element that was. First one was copper, right? This is going to equal the parts per million of copper times the dilution factor, right? That divided by, oops, sorry, not the uncertainty, times the dilution factor. That divided by that, and then times 0.1 liter. Right? So that comes out to exactly the same numerical value, right? Only now that it's in units of milligrams, right? Oh my gosh, such a big deal there, right? Well, now what we want is the estimated standard deviation in this value, and that's where a little bit of work comes in, right? And what we can do there is we can bring up the oops. This is from the lab manual, page, let's see here. This is page 78 of the numbers in the lab manual, or page 83 in the PDF. So this here is how to get the uncertainty for, if you have a number x that's equal to A times B over C, right? And this is the milligrams of copper, for example. That's A times B divided by C. So the way that we do this product and quotient is we do it like this. We could also do it in the way we did earlier, which is x over a, x, or a over x, b over x, c over x. That works exactly fine too. This is exactly equivalent to that. Let's just use this one here. And so we want to express this formula times x, right? So what we're going to do in this formula is we're going to say equals the concentration, oops, I'm sorry, the ppm value times the square root of, right, I've got the square root of one quotient squared plus another squared plus another, oops, squared plus another squared, right? Actually, that's one too many there, isn't it, I think? Yeah, that's one too many. So there we go. We got the three values, right? So we're going to have, now each of these values is going to be uncertainty divided by value, right? Oh, no, we will have four terms here, right? Because we have the actual answer, right? Sorry about that. So we'll have, we can do the answer squared. So that's going to be that divided by that plus, get it right there in between those parentheses. Now we got that divided by that plus, oops, that divided by that plus that divided by that. Okay, now I'm going to hit enter, and that should do it. So this goes up from 0.08 to 0.012 there. I think that is correct. And yes, that's correct. And now, so now we have a way to go from the amount and standard to the amount in standard deviation. Right? And this fraction of this is a little bit smaller than this fraction of this, right? So this went up by maybe 50%, right, in this last step. So in the unit here is going to be milligrams per tablet, right? So I'm going to type mg space tab to the -1. And in order to get it to write -1 up here, I'm going to highlight it, say control 1, go superscript, and OK. There we go. So now this can all come down here. And this guy I'm going to copy in a different way because it messes up otherwise. Okay, so there, now we've got amount and standard deviation milligrams per tab for each of these, right? So remember, I think the label said 0.5 for copper. Now we got 0.488, 0.46, 2.06, 2.06. There's the blank, which came out negative. There's absolutely nothing wrong with that because it's super small. And then there's the validation, and we have yet to determine what the actual value is on that. Now, there is one final step here, which is go to the confidence interval. And in order to get the confidence interval, once you have the standard deviation, all you really need is the 95% confidence interval. So you can go up and you can say 95T4, let's say, and that we can say that that's the 95% confidence interval. And that's going to be equal to T dot inverse, and the probability is 0.05. Actually, I'm sorry, 0.95. And the degrees of freedom is 4. That's 6 calibration points minus 2, right? And I'll say enter there. That value is 2.1. And so the standard deviation is 0.12. The confidence interval is TS over root n, so that it's going to be equal to, oops, let me give this a name here. This guy, we're going to name it. Create from selection, top row. So this is going to be equal to T times S divided by the square root of 6, right? And that's 0.010, right? So it's just a tiny bit smaller than that value. And now another way to express confidence interval is as an upper bound and a lower bound, right? So there's a lower bound and an upper bound, right? So I'm going to scooch over here and let's do this guy. So the lower bound is going to equal the mean minus the CI. The upper bound is going to equal the mean plus the CI. And now we can copy all these guys down. Oops. There we go. And these are all milligrams per tablet here. Now what I will leave for y'all is to evaluate these guys. So you want to see how the range, oops, I got something wrong here. This is not right. I have a mistake here. This is supposed to be equal to that plus that, sorry. What you're going to do is you're going to look at the difference between this and this, and then the nominal values, right? So nominal is 0.5, and you're just going to ask yourself, is 0.5 in this range? And you're going to say yes or no. Is 0.5 in the range of 0.478 to 0.498? Well, no, it's slightly above that, so there's a significant difference, right? It's very small, but it's significant, right? It's also larger than this one, right? And then we got to look at, in this case, we're going to have a spike recovery here. And so this is going to be a percent recovery. Yeah, here and here. And then this is going to be the base, this is going to be the blank baseline. And then this is going to be, we'll also have a percent difference here. Right? So, so for example, we can have a significant difference here. In both of these cases, that will be yes. And then the percent recovery will be, it's basically going to be this minus the average of these guys minus the spike divided by the spike. So there's a formula for that. And let's just say that the spike was 1.5 milligrams. So let's say that spike copper is going to be 1.5. I'm not sure exactly what it was, but if it was exactly 1.5, we could do it like this, right? Spike for copper. I'll make a name for that guy. And then the percent recovery is going to equal that minus the average of these guys, right? Divided by that guy, right? And now we're going to format that as a percentage. We'll just use the percentage key, right? It's 107% recovery there, so that's not bad, right? And then we can do this one, do the same thing. We'll put dollar signs there. I'll just for both of those guys. Put F4 on both of those. And then I can copy this guy down there. Yeah, and it's exactly the same value because 2.097 and 2.098 don't differ significantly. Oops, except I used the wrong value. It's not AB10, it is supposed to be 2.064, there we go. So it should be 105. There we go. And then this is really small. CI of 0.01, so this is acceptable. And then the percent difference from expectation here, this depends on the validation for copper. Let's say the validation is 2.00, just to guess, right? I don't know exactly what they are, right? I can put this guy in, formula, create from selection, okay? And then the percent difference here will equal that minus that divided by that, and format that as a percentage, right? Minus 3% spike minus 3% difference, and that is, that's very, very acceptable. Even I just made that up, right? So all right. So I think that's all we need for this report, and you want to do this and get the figures, format these as tables, put them into your report, and then do a little explanation of the results as though I were your customer, and you don't have to go into the technique at all. Just talk about the results, and that will be that.